Hello, everyone. Good morning, good evening, good night for wherever you're in the world. Hoping you're doing great so far. I'm Dario Gonzalez. I'm a Sigma member, and I have the pleasure to be your host and moderator for this event today. Welcome to Sigma Offline Webinar. Right, so today's webinar is called Unlocking the Power of Open Source Remote Sensing, Introductions to Google Earth Engine for Environmental Data Exploration. It will be presented by our guest speaker, Dr. Abhishek Kala. Before start, let me give you a brief introduction of Dr. Kala. He is currently works for Occidental Petroleum Corporation, Oxy, in Texas, as an advisor in geomatics and remote sensing team. His educational background includes a PhD in environmental science from University of North Texas, master degree on geospatial information science from the University of Texas at Dallas, and a PG diploma in data science and business analytics from the University of Texas. Also, he has a strong knowledge in the domain of geospatial analysis and environmental science through more than 17 years of experience in GIS, remote sensing, geostatistics research, and geovisualization techniques. Moreover, he has a solid background in managing complex geospatial data, creating an efficient workflow, performing ETL operation, conducting spatial analysis, and utilizing machine learning models. In addition, Dr. Kala has made a significant contribution to the academic community. As a first author, he published 3 peer-reviewed research papers, 2 books chapters, 2 articles, and 2 conference publications. Also, he has been present his work in 14 conferences and academic events. Moreover, Dr. Kala has actively participated in the academic review process for various STEAM journals, including Science of Total Environment, Remote Sensing, Sustainability, International Journal of Health Geographics. He has further reviewed 2 books proposal for a novel publisher, Wiley and Springer, Nature. He currently a member of the Remote Sensing Subcommittee and the International Association of Oil and Gas Producers. Furthermore, student mentor of University of Texas students since 2020, guiding and supporting them in their academic pursuit. In 2021, he served as a student intern mentor for the Montreal chapter as a global nonprofit organization dedicated to social and environmental causes. All right, it's a wide background from Dr. Kala, and I would like to thank you for being with us today. For all audience watching this video, questions or comments can be written in our YouTube channel in the corresponding section. So please leave your email, and also you can send us directly to our email at info@sigma.org, and it will be answered. So that's all from my end so far. Thank you, Abhishek, for joining us.
Good morning, and thank you, Dario. Thank you, Alex, and hello to everyone listening to this webinar. Before I start presenting, I would first of all like to thank Sigma for giving me this opportunity to share my knowledge on this topic. So it's pretty interesting to me, and at least it's kind of an introduction to an open source remote sensing. So I'd like to start by saying that, as you know, that there is a vast amount of remote sensing data available from satellites, providing valuable insights to the planet's dynamic environment. But there is a big challenge for most of the facilities, organizations, persons that in order to download and analyze this data because of its sheer volume and complexity. So it's not easy, even if you have processes in hand, it's not easy to manage and do some kind of an analysis for this huge data set. But fortunately, Google Earth Engine offers a remarkable solution to this challenge by giving access to more than 40 years of historical and scientific data set from various sensors, including the optical, radar, and thermal. I mean, just to include few of those, and thus providing a comprehensive view of our planet's changes over time. So let's jump on to Google Earth Engine. So what is Google Earth Engine? It's an open source cloud-based platform that offers a vast array of geospatial analysis capabilities through a web browser. So simply what you need is just a web browser, a login, need to register, and that's it. It empowers users to connect, access, analyze, and visualize planetary scale geospatial data sets, leveraging the power of Google's computational infrastructure. So everything that you are working on is running on the Google server. So you have the power of Google, and everything, whether it is downloading the data, analyzing, everything works on the back end. You get your results pretty fast. Google Earth Engine offers a wide range of remote sensing tools and algorithms to analyze and visualize complex geospatial data. It supports popular open source programming languages like JavaScript and Python, which makes it widely accessible to most of the users. So these, if you know, I mean, these are most commonly used languages, and that is what Google Earth Engine also supports. So there is a huge scope of user base, companies, organizations getting a hold of its capabilities. It also fosters collaboration and knowledge sharing through its online community, where users share their codes and applications. So once you get into or you are introduced to how to use Google Earth Engine, you can join this community, and whatever questions you have, I mean, people have been doing it for years now. You can share your knowledge, you can grab, connect with those of the similar interests. So it's a very strong community. Okay, so this is a very, I'll say, the most important and interesting slide, I will say, because that is what Google Earth Engine is all about, I'll say. It consists of a comprehensive data catalog that hosts a vast archive of geospatial data sets reaching petabyte scale, so huge. It encompasses diverse data sets, including satellite and aerial imagery, environmental variables, weather and climate data, land cover, topographic, socioeconomic data sets, just to include few, right? So huge data set. These data sets are pre-processed and made readily available for analysis. That means it's not that you are processing them before you start using them for your analysis. That big task is already done for you. Through the Earth Engine API, users can seamlessly access and analyze both the publicly available data sets and their private data sets using a library of operators. That means Google itself has provided you the access to all these data sets, but you also have the flexibility to ingest your own data like shape files or TIFF files, whatever you want, and run these processes on your own data. And you can keep it private without sharing. So you can visit the link I have shared here. You can visit this link to explore the massive list of data sets that this catalog contains. And you will notice that it has all Landsat data that USGS has. It also contains Sentinel-1, Sentinel-2, and MODIS terrestrial composites. So let me click this link and let's explore what it has. Okay, so if you notice on this Google Engine catalog, although it's, yeah, I mean, whether it is elevation data, topography, imagery, any of the socioeconomic demographic variables, SAR data, I mean, it is huge. If I keep browsing, it will keep going on. And as I said, it's like petabytes of data which is there. And simply what you can do is just with one line of code, you can bring it in your code and use it. So going to the next slide, I'd like to talk about another very, very powerful an interesting tool, an engaging tool, I'll say, in Google Earth Engine that visualizes Earth's surface changes over time. So it combines numerous satellite images taken over several years and turns them into a captivating video. That is what is time lapse. And as you can see on the right-hand side, all these images are showing you some of the urbanization, the river meandering, deforestation, some of the examples, like what all capabilities you have with just few lines of codes. Users can explore various phenomena like urban growth, deforestation, natural disasters, and study long-term trends. Time-lapse, I'll say, serves as a powerful storytelling tool for communicating complex concepts and exploring Earth's dynamic processes and their societal implications. Let's explore some of interesting examples of different phenomena. I have this link here to show. Okay, I mean, you have all these projects, things that are done to explore. The first one is an example of Columbia Glacier retreat, right? How it was that glacier was there and how over the time it's retreating. So again, things may look very simple and straight, but this is not that easy. It is a huge data set, like years of data, and once you superimpose, you do this time lapse or trend analysis, it takes a lot of resources and time. But Google Earth Engine has made it pretty easy and simple. And one of the examples later on in the demo, I'll do the same and show you how simple it is. Let's see another example of, let's say, urban growth in Vegas. So pretty interesting examples here on different aspects that you can explore through this link. I don't want to go through all of those, but just want to show you some of those in order to give you an idea of how easy or how powerful this whole platform is for studying such processes, right? So this is another example of river meandering or changing rivers changing course over time, right? So let's jump back to the slides. Okay, so now how does this awesome Google Earth Engine platform work? With the cloud computing in Google Earth Engine, it's like having a specialized supercomputer for geospatial analysis, as all the computation is handled by Google servers, right? So the heavy lifting job, I'll say, is done by Google. And what you are doing is some basic level of scripting, not super complex, and you have lot of examples to follow, right? So it's not, even if you are not from a programming background, anybody can learn it. It's simple, I'll say. I'm not a programmer myself. Your code in the code editor is converted into instructions and sent to Google for processing. The analysis runs simultaneously on multiple computers, and you receive only the requested results, whether it is statistics, charts, map tiles, whatever you say. So in order to use Earth Engine, you simply need an internet connection and access to its integrated development environment through this link. Once you click this sign up, that will be the first step if you haven't signed it up yet. So what you notice here is through this page, it is asking you mostly what they have done. I mean, because this presentation is all about open source platform, it is available free of cost to students, researchers, non-profits, right? So you don't pay anything. You can do all kind of analysis for free. But for commercial purposes, there is a separate licensing, right? You need to pay a cost to it, and that can be done by communicating through Google staff. If you see here on this page, it says click here for a sign up form. And as soon as I do it, it says thank you. Because it's saying because I'm already signed up for it, right? In your case, you'll be navigated to a form, and your request, it may take a couple of days before it's approved, right? They'll ask you for what is the purpose of this? Is it a non-profit or for own research purposes? Those kind of basic questions, and it may take a couple of days before the request is approved. So let's go to the slide back again. So the integrated development environment provides various tabs for different functionalities, scripts, like scripts, docs, and all these things. So this particular snapshot, what you see here is how this platform looks like, right? And what I'm trying to tell here is there are tabs for where your script is documented. You write your script here. All your scripts that you have done over time and the other examples through Google, they are on this side, right? And I'll show you the real, instead of a snapshot, I'll show you the real platform. Let's do that. I'll go through. I have, okay, here, one of the tabs here. So this is what you notice. This is exactly the platform that you will see when you go the very first time, right? New script. That is where you are going to write your own script. And if you notice on this side, which says scripts, is owner. So in this case, it's me, the owner. I have my list of scripts over time, whether it is mine or I kind of modified, tweaked somebody's script and saved it in my account. Different categories, you can create groupings, whatever you like. Then there are some examples, right? If you are new, there is huge documentation which is already there. So if you want to learn something about charts, something about cloud masking, or any other things. I mean, there are a lot of examples to follow. So that is on the script side. On the docs, there are all different functions that Google Earth Engine has. So you can, again, learn how to use a particular syntax, right? For example, for image collection, like what all you can do. You can aggregate several years of data, like, and create a mean imagery, mean statistics imagery for that thing. You can have something on the projection, what kind of different projections you use. You can do some kind of a filtering, querying based on the different dates. So there is all those kind of things. You can go here and try to understand the syntax. Assets is a place where you can upload your own data set. So if you notice here, it says new. You go to shapefile, geotiff. As soon as I click this, it will ask me, and I can browse and upload the data set, right? I'm not going to go through this process, but I want to show you where you can do. So you can do geotiffs, shapefiles, those kind of data sets, right? And I believe KML also. So that is your own data. And if you see, if I expand my username here, these are different data sets that at some point in time I uploaded, right? That's my private data. If I choose to share it with someone else, I'll have to give that permission. Otherwise, it's not that you upload there and it becomes public, right? Just to give that as a note. As I mentioned here, this is the main area where you are scripting. Once your script is done, saved, you can share your script just with a simple link. So in this case, I just copy here. This is the link. I'll send it to my colleagues or friends, and they can click it and run it. I mean, unless it has some kind of a private data, you may have to give them access to your data set as well. But it is as simple as just sharing this link. Other than that, I'll say, and I'll touch upon this later on, is once your script is done, you can even create applications. So Google Earth Engine, this is more scripting, but you can create apps, right? You can create apps out of your scripts with this particular option, which it says. So here it says no apps to display, create a new app, right? Simple. So apps basically is an interface where you can add some tools, swipe this, different widgets, and use your back end map and script to display the results, right? For users who are not familiar with all these scripting, you just want to make this interface easy to access for them. Then on the right hand side, if you see, it's called inspector. So it gives you a place where you can explore your data, right? So in this case, because I do not have any data, but if I click anywhere on the map like this, it is giving me that this is the location, right? The point location where I just click. And this is the lat long, this is the zoom level, right? So these kind of details are very useful when even during your scripting, because you want to say, okay, I want to run some kind of analysis in Venezuela, right? So and so I will say that, okay, use these lat longs and zoom to this particular level, and once you run the script, the results come just zoomed into that region of interest rather than showing everything like in the map, right? So that's pretty useful. Console here is the place where if you run across some errors or issues in your script, it gives you those red scary things that says, okay, your line number this has some issue because it doesn't exist, right? Or you need to do that. So it is just like a place which helps you fix your bugs in your script. And lastly is the tasks. Task manager is a place if you have to run a long running task, right, which may take almost few hours to a day, right? This is a place where you can start those kind of tasks. So that is the interface of this whole platform, very simple and easy to use, right? And this, what we are doing here on the scripting side is JavaScript. So let's come back to the slide part. And I kind of covered all these things. So let's jump on to the next. Now, I want to give an idea, like see this presentation or webinar, I want to introduce you guys to this platform. After that, it is a simple, slow process of learning with simple examples. And for this, as a beginner, I've just tried to have an example where I'm trying to show with few lines of code what all you can do, right? So in this particular example, I have 3 demo scripts, but I'll initially focus on script 1. So this particular script, just in few lines, what we are doing is we are trying to pull and extract Sentinel-2 satellite imagery, right, data set. It clips to a region of interest. So I will say that I'll just draw a polygon around a particular area, and I'll say whatever Sentinel-2 imagery for that region is, clip that. Zoom to, once the result is done, just zoom to that region of interest, calculate some NDVI, some vegetation indices like NDVI, some water index, NDWI, and do some different band combinations using the Sentinel data. Finally, this data of NDVI, NDWI is added on the map. So you have that place to visualize your results as well. So because it's an integrated platform, right? So both these layers are added on the map, and you can visualize it based on the palettes or the colors you want to say. So in this case, if you notice, this is the NDVI imagery and this is NDWI imagery, but the way you can play with the symbology and colors using this palette in just a couple of lines of codes. Finally, this clipped imagery for that region of interest is added on the map, and that's it. And I'll show you that. And let's go to, I've just linked it here. Clicking this, it's simply taking me to the script, right? Although I could have, if this site is open, I can simply go here, and the way I've organized things, I expand this demo, and I have something called Sigma 2023, and I just realized it is SIGGMA. Sorry about that. So just a few lines of codes here. I already explained what it is doing, but you noticed the first line. Basically, what it is doing here is pulling the Sentinel-2 imagery. It is filtering for the bound. So bound here is a simple polygon. So I created a polygon here, right, near the Houston area. So I just said, okay, whatever I'm running, whatever I'm doing, just do it in this particular polygon area. So you can draw whatever you want like this, right? And that's it. What I'll do is just to refresh. Yep. Okay. Then what it does is I'm saying run this particular analysis or filter this imagery, because Sentinel-2 imagery is going on for lots of years, but I'm just filtering the data for 2022, right? So January till December. Sort cloud coverage assessment, what it is doing is, it is because a lot of images have cloud cover. We don't want a cloud cover image, so it is sorting all these imagery, stack of imagery based on the least cloud cover. So you will have the cleanest and the neatest imagery on top. So this is just in few lines, it is filtering the data for the region, for the cloud cover, and for the dates, right? Next, what we are doing is once whatever once we run the script, it zooms into this area only. I don't want to see somewhere else, although the analysis was for this particular area. So I have done that. HOU is I just abbreviated for Houston, and 10 is the zoom scale. Then in just one line of code, what I'm doing is I'm using band 8 and band 4 to calculate NDVI. And in case of NDWI, is the water index, is band 3 and band 8. It computes those indices and uses this palette. So I'm saying for NDVI, use red, yellow, and green colors in that order of like how the values increase, right? So highest is green. The same way for the water index, blue is highest, right? So use these color palette for visualization purpose. Final step, what it is doing is it is clipping this NDVI and NDWI data just for that region. So let's run this. I commented this so that it doesn't just immediately show the result. I want to show you how fast the result is. So this is just few lines of code. All I have to do is run, right? It ran, and there you go. The result is there. What you see here, that's NDWI, and this is NDVI, right? You have the option of adding a satellite imagery on back just to explore more. But that is it. I mean, it is so simple, few lines, not big deal. I mean, easy to understand this scripting, lot of examples there, a very strong Google Earth Engine community. You can discuss, ask questions. I'm pretty sure you will get all your queries resolved because it's a huge community. Another example I wanted to show you is animation, right? So this is another script in which what we are doing here is I'm running it. I just did it for the Venezuela area, and just in, let's see how it's, what it is doing in this window, it created a thumbnail, and this is showing an animation of vegetation NDVI change over time, right? Here, what I've used is the modest imagery, computed NDVI, and it is just for 2022 to June of this year, right? Till last month. So on this time, this is how things are changing. You can make it even more powerful by adding the labels on top, like how this over the time, how the things are changing. So you can do a lot of things, but it is just one simple example. And last script that I wanted to show is, because all this a particular webinar presentation is trying to also show on the environmental data or aspect side. This one is another one to show is for a soil moisture, right? So what I'm doing is, this script is giving us like not big script, but it is giving us that flexibility of having this cursor. You click on the map anywhere, and it is using the what do you say, the soil moisture data, right? Which is coming from from like the data catalog, pulling that, and this is for 2020, right? January to December. So whatever point you click, you can see the trend, how the soil moisture for that particular location over the time, right, in 2020 is, right? So just a couple of examples, few lines of codes to show and demonstrate how powerful this platform is. So that is it on the demo side. Let's see what we have. Okay, I'll like to, before I conclude, right, demonstrating, showing what all this thing can do, I like to mention about the Google Earth Engine app. So while showing you the platform, I even gave you that particular demo that how you can, where you can click and create these apps. So these are dynamic shareable user interfaces that leverage Google Earth Engine's data catalog and analytical power, right? So whatever data is there, you can bring it in, you can add some tools, widgets, and use that analytical power in simple to use apps. These apps help users to explore and present complex geospatial phenomena in an accessible manner. So let's explore a couple of these applications that are powered by Google Earth Engine. The first one I'll show is the Global Forest Watch, which allows users to monitor and analyze global forest cover and change. So let's go here and see. Just wanted to give you an idea about what other products or outputs can be created out of this Google Earth Engine, right? And it's all free. Um, so this is one of the applications. Let's see. Okay. So if you notice, I mean, it is, although there are different vendors, companies, it's like a collaboration, but on the back end, if you notice, is a Google Earth Engine, right? That is, data is coming from Planet to run all these analysis. And what you see here is a simple map. You can run all these things just to see how the trend is over the time. So it's showing 2001 to 2022 tree cover, right? So red here displays a loss and green is where it increased. So let's run. I mean, this is how the changes are. So again, this has a lot of things, very, very powerful. On the back end, you see you have options of analysis with the political boundary, this and that. I'm clicking here, analyze, and let's see. So what it is doing is, for this North Dakota area, it is giving us some statistics, right? Again, I'm not going to go deep into this. This is one of the examples of an Earth Engine app that you can create as a final product as well. Let's go to the second one, which is these are few examples. I'm not going to go through all of them. Last one I'll try to show is the Global Safety Net Viewer, which provides an interactive platform for exploring protected areas to safeguard biodiversity worldwide. So let's explore this and see what all it has. Again, the backend is all powered by Google Earth Engine. Very fast, easy to use. And let's see. Okay, so again, if you notice, it's powered by Google. Backend is Google Earth Engine apps, right? All it is doing is using all this imagery data, all this stuff. It is doing all unprotected areas like rare species sites, all this stuff. Interesting environmental related applications, very, very useful for different organizations, individuals for their research. And the same is something that you can come up with, right? Very interesting for those who are into academics and research. There are tons of other applications, but we can't go over all of them in this short period. And I'm pretty sure that you will explore this platform and create some awesome scripts and apps, and I'll be the one exploring them soon. So let's go. And that's it. I mean, that's it from my end. I know it is in a short time, I spoke a lot, told about a lot of things, but I try to cover the important aspects of this platform, what all you can do. If you have any kind of questions and I can help, this is my contact, and you can connect me through LinkedIn as well. My LinkedIn handle is here, and that's it. Thank you very much.
All right. Thank you, Dr. Kayla. Thank you for your time and presentation. It was very, very interesting. And I see GEE is a powerful platform can use for meta-analysis, and it's a great opportunity for our viewers to see what happened and do any kind of analysis.
Yep, for sure.
Yeah, Dr. Kala, I have a few questions for you.
Sure.
Apart from JavaScript and Python, what other programming language does GEE supports, and how can be used for geospatial analysis?
See, I'm not sure if, I mean, to my knowledge, up till now, I know that this is mainly it is the JavaScript, the online platform is through JavaScripting, right? Which I just give demo is that easy, straightforward. Those who have a background and some experience working with Python, and there is a huge community with this open source programming language, right? They have that Python API to pull in this data sets, run some analysis, do some data science related things, because Python is very, very powerful, and it has a lot of additional libraries for data science as well as visualization, right, that you can pull in. So those are the two main things. I am not sure if they have integrated anything on the R, right? If R has anything, but those are the two main ones. I know that even those who use QGIS, there is an add-in, right? Again, that's not talking about the programming language, but they have an add-in that for Google Earth Engine that they can directly bring in and pull the data from Earth Engine and run some analysis on QGIS.
Okay, yeah. So another question, can you recommend some resources for further learning and exploration of this platform?
Yeah, sure. So let me see, am I still sharing? Oh no, it's paused. Sure. Okay, so good question. And my last slide, which probably I kind of kept it in the end, is, can you see that?
Yes.
Yeah. Okay, so these are some of the useful resources, and there is not just limited to this, but these are few which I thought that may be useful. The first one being how to set it up, which I, in one of the slides, I've also mentioned earlier. This is the main GitHub page, which has a lot of huge repository of these Earth Engine scripts that you can utilize to learn. Then the community, right, which you can join. And I will just suggest anyone who kind of gets interested after this webinar to want to start exploring it and find it interesting and useful for what they do, definitely join this community, because you may, I'm pretty sure, even though it might be straightforward, you may have a lot of questions, right? And this community is very, very powerful and helpful, and you can just simply send some questions there and you will have an answer pretty soon, I'm pretty sure. Some other articles, research articles, and some YouTube videos that I thought that might be useful to at least share. So yeah, to answer your question, that is it.
Okay. Yeah. Another question: how can we do image fusion or fusion or multi-sensor data using an available function in GEE?
Okay, so when we talk about image fusion, right? So you can use some different band combinations. You can use some different band combinations, or even you can fuse the imagery coming from multiple sensors, a different resolution, using some simple functions like I'll say there is something called add bands, right? In Google Earth Engine, there is a function called add bands where you can use one image and fuse it with the other using this particular add band function. Another one is, I think, is a merge function, which can be used for that. So there are things, and again, as I said, on the platform itself, on the left-hand side, there is a library of all those functions available and the syntax of what you need to use to further explore it.
Yeah, interesting, very interesting. Well, there's no further questions. So on behalf of Sigma team, I want to thank you so much for your excellent presentation, Abhishek. Very interesting and novel topic. I think is a very good beginning for the beginners, students, or all professionals that don't know anything about that, but this is a powerful platform.
Yeah.
So
thank you very much, Dario.
Thank you. Yeah, I would like to thank you, and thank you the team that has made our event possible by being attentive to every details, and finally to all our audience for the interest on this webinar. And I hope you enjoyed this presentation and found it beneficial and valuable. So as a reminder, you can leave your comment or question in this video with your email address, and it will be attended as soon as possible. Before concluding the event, I would like to invite you to attend to our social network, YouTube channel, and website, so you don't miss any details or upcoming events. So that's all for today. Hoping to see you soon. Stay connected with Sigma Global Network, and thank you so much, everyone.
Thank you, everyone.
Bye.